Hello and welcome to today's notes, elements, and compounds. I'm going to keep my screen in preview mode just because I don't want this the Chrome sharing thing to block any of the important information. So I'm going to keep it small like this so we can make sure we see all of what we need to see. Let's get started. So let's review elements really quick. An element is a pure substance that is made up of only one type of atom. Let's say it together. An element is a pure substance that is made up of only one type of atom. So if you're looking on a periodic table, that would mean there's only one capital letter. Each element has its own properties, both physical and chemical, that differ from other elements. And because they are a pure substance, they cannot be broken down. They only have one type of element. So here are some visual examples with models. You can see in our first example, number 2, that it has one shape and it has one color. Each square represents one atom of the same element. So because that red square symbolizes hydrogen, and there's 9 of them, it would be 9 hydrogen. And this is the element symbol, capital H for hydrogen. Our second example, which is number 17, those triangles represent carbon. But you can see that there's multiples of them. So we have 1, 2, 3, 4, 5, 6 total, but there's 3 in each of them. So how would we write that? Well, each group of triangles represents multiple atoms of the same element. So there's 6 groups, so we would have our 6. We know that the element is carbon, so we put the element symbol for carbon. And because there are 3 of that specific element in one group, you would add a little subscript with a 3. So that tells us there is 6 groups and there's 3 carbons in each group. Let's go on to some more examples. So we can see that there are multiple shapes and multiple colors. So our square is hydrogen, and I don't know what that is. Is that a pentagon, a hexagon? I was never good at shapes, but that's going to represent nitrogen. So they're not attached, so they are different elements. And each shape represents one atom of that given element because they're solo. So the squares are solo, our hydrogens are solo, and our nitrogens are solo. So we have 8 squares, so we would have 8 hydrogen, and then there are 5 of the nitrogens. So we would put a 5 for the nitrogens. But what happens if they're grouped? So again, we have our triangle for carbon and we have a circle for oxygen. So now we have different colors that are not attached to each other. So each group of shapes represents multiple atoms of the same element. So let's look at carbon. We have 1, 2, 3, 4, 5, 6 groups. So we have to put our 6. We know our element is carbon based off of our little legend up here. And there's 2 of those carbons in each group. So we're going to add that 2. Same thing with our oxygen. We have 3 groups of oxygen. 1, 2, 3. So we put a 3 for groups. There's our element symbol. It's kind of cut off. And then you would put a little 3 for the subscript. So like carbon has a 2, you would put a 3 for our oxygen because there's 3 circles here. So let's get into compounds. A compound contains atoms of 2 or more elements which are chemically bonded. And each compound has different properties than the component elements. Compounds can be broken down. So where elements, you cannot break them down because it's just one element. With compounds, you have multiple elements coming together to form a compound. And those you can break down by separating them. And as you can see, we have different shapes here that are connected or different sizes and colors. And you can see that we have multiple capital letters. So remember, if it has multiple capital letters, then it's a compound. Elements only have one. Different properties. So each compound has different properties than the component elements. But what does that actually mean? So if we look here, our end point is salt, sodium and chlorine. So if you make a compound with sodium and chlorine, you're going to get salt. But if you were to break down sodium and chlorine together, so if you break down salt, you originally have a sodium and you originally have a chlorine. So those are your elements. It's kind of like a compound sentence too. Compound sentences, you have two sentences that you put together with an and. So in a equation or in an equation, you have reactants, which are your original elements. So in our case, sodium and chlorine. And together, when they form chemically together, they become salt. That is our product. So product's what it makes. And when we're talking about the component elements, we're just referring to the fact that sodium looks one way and chlorine looks one way as reactants. But when you make a product with it, you get table salt. So how do they look in a visual model? Well, you can see more than one shape and one color, and they're bonded or they're attached to each other. And that's how you'll know that they are going to be compounds. So you'll have the different shapes or the different colors attached to each other. So in this case, we have carbon and oxygen, and they're attached to each other. And so we have 7 of them. 1, 2, 3, 4, 5, 6, 7. So it's going to be 7, and then you'll write your element symbols. Same thing with our example 8 right here. You can see more than one shape and color, and there are 2 pairs of bonded shapes. So there are 2 compounds here. We have carbon and hydrogen, and then we also have oxygen and nitrogen. So those are going to be 2 separate compounds. And our last model, you can see more than one shape and color together. So we have nitrogen, oxygen, and hydrogen in this group. And then we have carbon by itself. So some of them are not bonded. So carbon in this example is just an element because it's by itself. And then there's some that are bonded, like our nitrogen, oxygen, and hydrogen. So how would you write that? Well, let's count our carbon groups. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 carbon groups, and there's only 1 of each. So instead of putting a 1, you just leave it blank. And how many of the other compounds do we have? 1, 2, 3, 4, 5. So we have 5 groups, and there's only 1 in each, so we just write the element symbols. So subscripts, we kind of talked about subscripts a little bit. That's that small number at the bottom right of an element symbol, and it tells you the number of atoms of an element within the element or compound. If there is no subscript, like right here, then there's only 1 atom present. So in H2O, that 2 goes with the H, goes with that hydrogen. So that's saying that there's 2 hydrogen atoms. Oxygen doesn't have 1. That is saying that there's only 1 oxygen. And let's end it with an example. So our subscript examples, this is saying that there's 6 carbon. The 12 is saying that there's 12 hydrogen atoms. And the 6 is saying that there's 6 oxygen atoms. All right, let's look at this one. Sodium, Na, does not have a number. That means it has 1 sodium. Our carbon has 2 atoms. Our hydrogen has 3, and our oxygen has 2.